spectroscopy, and then principle is there, and here instrumentation and diagrammatic view, and fourth column is applications, about the applications. Okay, in this today's class we have to discuss about the atomic absorption spectroscopy. Main, what are the total spectroscopies which are presented in our book? We have to discussing about that. Okay, simply atomic absorption spectroscopy. In atomic absorption spectroscopy, the main principle is absorption of atoms. Here you can observe the instrumentation is about the halo cathode lamp, and then dropper is there, and then flame is presented, and sample solution is there, and one monochromator is there to filtrate the solution, and detector is presented, and finally the recordings will be observed in the readout device, nothing but amplifier. This is the instrumentation and diagrammatic view of atomic absorption spectroscopy. And when we move to the applications, this atomic absorption spectroscopy used to estimate the elements and calcium carbonates, and also to estimate the soil samples and some biological products. Okay, and then second one is ultraviolet spectroscopy. In this ultraviolet spectroscopy, the main principle of the ultraviolet spectroscopy is absorption of elements. Where it comes to the instrumentation, source of light is there, lens is here, and monochromator, which is nothing but filter, and a sample is presented, and readout device. Applications of ultraviolet spectroscopy: to estimate the quality analysis, and to detect the impurities, and to detect the organic compounds in drug, and also ultraviolet spectroscopy used to analyze the compounds, determination of molecular weights, etc. Third one is fluorimetry. What is about the fluorimetry? The main principle of the fluorimetry is emission radiation. Emission radiation, which is produced from the light. Okay. Here instrumentation is about the source of light, monochromators, sample, and readout device. Here the in fluorimetry, the emission means the molecules, atoms will be excited, or from the ground state to the excited state, will move from the ground state to excited state. Okay, you can observe here, that is called as fluorescence. When the atoms moves from the excited state to the triplet state, it is called as phosphorescence. When atoms are moved from the triplet state to the ground state, it is called as phosphorescence. And the main applications of this fluorimetry is to determine the inorganic compounds, and to determine the wavelength of the bonds which is present in between the carbon and hydrogen atoms, and to detect the chemical reaction, to analyze the organic compounds, etc. Fourth one is infrared spectroscopy. In this infrared spectroscopy, the main principle is vibrational frequency. When the frequency of vibrations will be changes, the recordings will be changed. So that's why here the source of light is there, sample is there, monochromator is here, and readout devices. A simple instrumentation of this infrared spectroscopy. This infrared spectroscopy used for mainly to identify the drug components, to study the polymers, to study the hydrogen bondings, and to determine the organic compounds. This is about the simple, this is the part 1 of the spectroscopy methods. These are 4 types of spectroscopy methods which are presented in instrumentation analysis.